Hi everyone. In this video, I want to talk about the capabilities of Azure AI Foundry. As right now, when we think about generative AI, we think about Microsoft, you think Copilots. Because there's a huge amount of Copilots out there, and Copilots are absolutely the right solution in many scenarios for many different personas, but there are way more AI capabilities available for those maybe more pro code, where I want to fine tune a model, where I want to do more agentic and more complex scenarios. And they are useful for everyone from your data scientists through to your AI engineers. Now, before I get to talking about Foundry though, I do want to talk about Copilots and where they do play and how they do maybe integrate with the Foundry. And it's important to understand there's a distinction when we use the word Copilot between capital C Copilot, the product from Microsoft, and then little c Copilots that you may create. So starting off, I can think about the Microsoft capital C Copilot. And I can think of these are Microsoft's AI assistant products. And there are numerous things around those. We obviously think about things like, well, there's M365 Copilot for the productivity suite. I can think about, well, there are one for Dynamics, there's Security Copilot, there's GitHub Copilot, there's Azure Copilot. There's a huge range of these. And these Copilots are really a next evolution in how we interact with many of those solutions. We went from text interactions to GUI interactions, and now these multimodality. When we say multimodality, it could be text is a modality, audio is a modality, image and video could be another modality. So we get more used to how we can interact with these solutions. And with the Microsoft Copilot, and for example, M365, well, it has capabilities often grounded in things like the Microsoft Graph and your data, but I can add maybe additional data into the graph. I can add some additional data sources. I could create my own kind of agent. And I would often think about, hey, those Copilot products, they're fantastic for knowledge workers. Hey, I want that assistant to help me with my various duties that I'm performing. It makes me more productive. And maybe even, hey, I want to create a little automation, a little trigger for something that helps for myself, which I can easily do with things like M365 Copilot. It even has a hook into things like Copilot Studio, which is the tool we're going to talk about. And then I can think about the little c Copilots. So if I think about a little c Copilot, this is your solution that you are building to help solve a certain task. It could be internal users, it could be your customers. So I can now think about, well, I want so you as the customer, your own little c Copilot. So these are not Microsoft product Copilots. These are things you're going to build yourself. So if the Microsoft Copilots don't meet your requirements, you can use tools to create your own Copilots for your scenarios. Now that could be because of certain functionalities, certain integrations, certain data sources I want to ground on, the experience, the integration you want. It's your choice, but maybe those Microsoft Copilots just don't fit your scenario. So I would start with the Microsoft Copilot, and then, hey, it's not meeting my requirement. I'm running into some limitation for maybe more advanced scenarios. So I want to create my own Copilot. And now we have choices in the tooling. So what are the tools we want to use to go and create my own Copilot? And so what I can think of from a tooling perspective, so we draw a little hammer for a tool, well, there's Copilot Studio. And the whole point of Copilot Studio is it's low code. So I don't have to be a pro code developer understanding C# or Python or whatever that is. It's a very low code type solution, but that means I may hit certain limitations for very advanced scenarios. There is a Copilot SDK. So from pro code, I can actually go and hook into those Copilot Studios. But with Copilot Studio, I can do a number of different things. I can build my own copilots. So I could think about, yes, I want to go ahead and create a copilot for my organization. Maybe it's a copilot for my HR scenario. Maybe it's something for my customers to hook into my sales catalog or book something, whatever that may be. Or I might want to use it to extend an existing copilot. And as mentioned, there is actually capabilities, for example, in M365 Copilot. As a knowledge worker, as a user of that, there's even a little link directly to it to help me go and create my own one. And one of the nice things about Copilot Studio is I just tell it the data that I want it to ground on. So ground on is, hey, when you are doing your creative, working out the response, as the model, it was trained on a certain set of data, which is not your data. So what grounding does is it makes additional data available that it will send with your request to the model that it can then do its inference, i.e. work out the response from. So this could be, I could add data from websites, I could add data from SharePoint sites, I could add it from the Dataverse, from Graph, I can add topics, which are particular areas I want it to be able to respond on. I can add generative AI into that so it can be more creative. And then I can add connectors, which gives it actions it's able to perform. And the nice thing is, when we say low code, I can use natural language in Copilot Studio to describe the agent I want, to describe and tell it, well, this is the data I want. And it will then go through and create what it believes is the right thing. And then I can go and confirm that. And I could go and maybe tailor things, again, all in a very low code scenario. So Copilot Studio might be fantastic for someone from the business or IT, where I want to create an agent to be used by my company, by my customers. One of the other nice things I can do here is Copilot Studio is a SaaS. I'm not having to bring anything to it. The models it's using behind the scenes are managed for me. But I can, if I want, if I have some kind of customized model that I've created, that I've fine-tuned, and I've done that in our pro code solutions, i.e. Azure AI Foundry, I can actually hook into that. So I can say, well, there's also this idea of Azure AI Foundry, and I can bring my own model. So Copilot Studio can hook into that and use a model that maybe I have tuned in some way so it can go ahead and leverage that. So then we come on to this idea that this absolutely is the pro code. This is maybe, hey, I want to build on some foundation model. I want to do tuning. I want to use multiple different models in one interaction. I want to integrate it very tightly with my application. I want to customize things around content safety, and I want to do evaluations and compare. This is the Azure AI Foundry, and that's the topic of this video. And the nice thing about Azure AI Foundry is I can really hook into it from nearly any tooling you can think of. Now, often we think about Visual Studio, VS Code, GitHub as primary partner tools, but it can hook into so much more. And so once again, when I think of Azure AI Foundry, it also absolutely could go and create your own Copilot if I wanted to do those things. Absolutely, again, it's a tooling. It could go and create extensions for the Microsoft Copilot. So I do have choice. Hey, do I want to do that low code? Do I want to do a pro code solution? But the really nice thing here is this can also really hook into any AI app I may have. So I can think about Microsoft Copilot is Microsoft's AI assistant products. Then you build your own copilots. So these are AI assistants. You build. And then AI Foundry, hey, I can go and do anything I want. So I think of all of those different things together, it can really boil down when I look at my options into three fairly simple things. And I could break that down really into the idea of my ability to customize. So my customization ability and the coding level that goes with that. So with Microsoft Copilot, I have a fairly low customization, and it's really a no-code scenario. With the idea of Copilot Studio, well, now I have a medium ability to do customization, and it's a low-code scenario. And then for Azure AI Foundry, it's a very high degree of customization, and I'm using Pro Code to actually hook into that. And again, there's a whole bunch of different integrations for all of these different capabilities. But Azure AI Foundry is where I'm going to live when I really think of my Pro Code type solutions. That's just going to be my home for all of the various things that I'm going to do. And it is that uniform platform. So there were Azure AI Studio in the past that has obviously been renamed and is now Azure AI Foundry. But a whole bunch of all of the different AI capabilities have been brought into Azure AI Foundry to remove some of that complexity we saw when we had all of those different tools, those different places we may need to go. So I can think of Azure AI Foundry as a collection of tools and services to fully create, manage, and use AI models at scale for those data scientists all the way through to my AI engineers. And you have to remember that Microsoft, when it builds its Copilot products, they're using Azure AI Foundry. So the same capabilities Microsoft use are available for you to build in your solutions. Now, as I think about what is Azure AI Foundry, I'm going to break it into just 3 primary topic areas. But as you'll see, there's kind of some gray areas between those. But at least let's break it down into what are those key things I may think about. And we're going to think about models, because we can't not talk about models today. We think about the idea of developer tooling. And then we'll think about safety. So I can think about content safety. I can think about also understanding, well, how is it responding? We think about things like evaluations, because our traditional mechanisms we may use to validate our application. Hey, we send a synthetic transaction through. We know if X goes in, Y should come out. Well, when it's generative, it's something called non-deterministic. That creativity that's inherent to these generative AI models means I don't know exactly what's going to come out of it for any given input. So we have to treat validating how it's performing in a slightly different way. So we think about evaluations. So safety is another core area I want to touch on as part of this. Now, when I think about AI today, yes, we always think about large language models, LLMs, and that generative AI because they generate content and that creative nature of them. But it's really important to think about when I say large language model and we obviously get super excited, it's still a machine learning model. Machine learning models at its very core basics are all very similar. They have different slight structure to them, but they're all a collection of weights and biases that link together the various neurons that make up the model. And those weights and biases are parameters. So the sum of those are the number of parameters that we have in our model. And when I think about a generative AI model, remember we have our input that is our prompt, and that is passed to the model. And then the inferencing happens, i.e. it's using a lot of mathematics based on the trained parameters and the probabilities to have a probability distribution, work out what is the most probable next token, which could be a part of a word. And then it does the next one and the next one. Even when you hear about reasoning models that seem amazing and they can do very complicated things, it's still working exactly the same way, but there are certain techniques to encourage a chain of thought, to break down a more complicated task into smaller tasks that it then runs back through and performs those. It's why when you use reasoning models, if you go and look at the billing, you'll see the idea of these reasoning tokens that you also pay for, because they're not part of the output, but internally it still generated that plan, that chain of thought that it then ran back through to get your ultimate output. So it's really important. This is what is happening today. And when I think about AI in the world today, there are really some key big trends that we see. I might just want to use natural language. I want multimodal capabilities. Remember, multimodal, I want to do text and audio, or text and images, or images and audio, whatever that means. I might want to use multi-model. So that's where I'm going to use multiple different models to solve and complete a certain solution. Because some models are better at coding, some models are better at maybe text to speech, some are very good at a very specific task, and they're cheaper because cost comes into this. Yes, maybe I could use this massive large language model to do everything, but I'm paying more for every token. Whereas there's maybe a small language model that for that particular task can run much faster and much cheaper. So it might be beneficial to use multiple models as part of my solution, but that adds some complexity. And of course, agents. We can't, I think, say AI now without talking about agents. So this is moving from potentially something just interacting with the user and helping us, giving us maybe some information, to it actually doing a task fulfillment. It's actually performing the task. And when we think about these agents, and I'll talk more about this, it's new considerations. Because when I think of things like, hey, a regular, for example, a Microsoft Copilot or one you build, and it's interacting and helping the user be more productive, well, the human is in the loop. So the AI is generating some content. Well, then the human can always have that step to validate and say, okay, yes, that makes sense. Or actually, can you tweak that thing? When you start talking about this agentic world, which is where it's still an AI agent. So agentic is really a subset of AI agents, but they're autonomous. They don't have to have a human in the loop. They can go and plan out a much more complicated set of tasks to fulfill the thing it's being asked to do. Or it may trigger off of some event like a change in a database row, or some email comes in. And when you take the human out of the loop, well, it adds complexity to that because, again, of its creative nature. You'll see things like make a checker pattern. So an agent might go and generate, this is what I'm going to do, this is how I'm going to respond. You'll have a separate agent that validates that, and they may bounce back and forth until the checker is satisfied that what the maker agent is saying is the right thing to do. But it's critical to understand that is just one type of AI service. So there are many other types when I think about this idea of models. So absolutely yes. And I guess I should draw this in the sparkly, everyone loves it. There's absolutely generative. And you'll often see those generative models broke into small language models and large language models. And the reason you have this distinction between them is normally when you talk about those number of parameters that they have, well, a small language model might be in the single-digit billions of parameters. That doesn't sound that small, but these could be in the trillions of parameters. And it's about, if you think of every parameter is a number. Now, it could be 8 bits, could be 16 bits, and there's optimizations that happen, but that takes up a certain amount of memory. So if I'm a small language model with single-digit billion number of parameters, well, that means it could probably run on a local machine. It could run on my phone. It could run on a Copilot PC, for example. It could run on an IoT device. And so where I may want to run it locally, these small language models can be really useful. Whereas the large language models with these massive number of parameters, I'm not running that on my phone. That's a very different scenario, but these will typically have a greater set of capabilities. There are amazing things happening though. So when I have a more targeted requirement, they're doing some really cool things with the small language models. So even a small language model, you'll find now can do multiple modalities. Microsoft just released a multimodal 5.4 model, a small language model, but it can do 2 of the 3 at any one time. So it could do a text and an image. It could do audio and text, audio and images. It's a text-only output, but there's some crazy advanced stuff going on in these worlds. But in addition, my point here is to the generative, there's the more standard type of models we have. So we do still have the non-generative. And these have been around for a very long time. So it's standard machine learning, where maybe I'm training the neural network to do some particular task that I need. It might be optical character recognition. It could be text-to-speech. And there are times where, for example, text-to-speech, there might be better neural voices available in these just specific text-to-speech models that's better than the neural voices that I can get from maybe a large language model that can do an audio output. It might be when we talk about creating those solutions, it's actually better to just have a text output and then feed it into a text-to-speech model to maybe get a greater voice, a greater set of capabilities there. I might have things like image classification. I mean, the list really goes on, but there are these traditional types that are more, I can understand what they're going to output for any given input. Might be labeling, classification, whatever that could be. And very often these are going to be the right solution. Depending on your task, don't just think now with AI, oh, I need to use generative AI. Absolutely not. The traditional deterministic AI solutions could absolutely be a better fit from a performance perspective and a cost perspective. Could a multimodal generative large language model detect if there's an orange or an apple or someone's in an unsafe distance from a piece of machinery in a factory? Sure, but I'm going to pay way more for the tokens and the latency, i.e. the time it's going to take to have the input and give me the output, it's probably going to be way longer than a traditional machine learning model that I trained on the scenario. So don't just think, oh, I need to use generative. That's not the case at all. So all of these are part of Azure AI Foundry as well. And I'm probably going to want to, again, use these things together. If I want to add generative AI into my solution, well, it may still be working with these more traditional type solutions. Now, just to note, when I think about the experience and these tooling, yes, the portal is obviously nice, and I'm going to mainly show the portal. But realize there's also a very rich SDK. Everything I do in the portal, I can also do through the Foundry SDK. So the portal might be the right solution when I'm trying to maybe do some kind of comparison between models, look at the benchmarks between them. Maybe I'm trying to do some analysis of, well, what's happening in this particular interaction? What is the tracing? But then the SDK is going to be the better solution if I want to integrate with my CI/CD pipelines, for example, where I want that more declarative nature of creating and configuring the resources. Everything there I can do from the SDK as well. And then, as I mentioned, the safety has a whole set of amazing capabilities that we're going to go into detail on. So to start with, I do want to talk about the models set of capability, because this is in some ways kind of the shiny star of this. And there's a collection of models that I can use just out of the box, but I can also update them. And you're going to hear a number. There's 1,800 models in the catalog. If we actually go and jump over for a second. So here I am. So this is Azure AI Foundry. You can see I've just gone to ai.azure.com. I'm in the Azure AI Foundry portal. I'm in this initial overview for a project. We're going to talk a little bit later on about what that is. But we see this idea of a model catalog. And straight away, I mean, I said 1,800. You can see there's 1,865 models right now. Now, this absolutely includes the more traditional models as well. And you'll see there's various ways that these are organized. So for example, I could look at inference tasks. So embeddings, hey, I want to create a vector that represents the meaning of some text. That's core to all of those semantic indexes and vector databases you hear about all the time. But you'll see there's also things like, hey, text-to-speech, translation services. Obviously, you're going to see things like chat, conversational, chat completion when we think of those generative AI type solutions. So here, hey, you can see there's solutions from OpenAI. You can see there's DeepSeek, which obviously just came out. We can see there's Llama, there's also ones from Mistral. So it's not just Microsoft, there's Cohere. So there's huge numbers of partnerships with all of the AI experts here. But I can also see those more traditional. Hey, a text-to-speech. Right, there's Azure AI Speech, the more traditional services here. So there's different ways that these are organized so I can go and see these capabilities. But we'll also see maybe it's based around a certain industry. Maybe I'm looking for a certain capability. Maybe, hey, which ones I can use for fine-tuning, different licensing. We'll see there are collections. And this curated by Azure AI is actually a pretty important one because it's where Microsoft come along and stamps it as enterprise ready. They do some additional checks and things on there. But if I was to look at the inference task for a second, and let's say we will actually go and look, if I could just do a type. So if I want to chat completion, so now it's showing me all of those chat completion models. And what you see here is, yes, you see a lot of OpenAI in this picture. And there's a very public partnership between Microsoft and OpenAI. They were that big, large language model that got a lot of attention with their sort of chat GPT and the underlying models of that. And there is a huge partnership on there. Every OpenAI model comes to Azure the same day it comes to OpenAI. But then what Microsoft does is layer on a lot of additional things. They have additional content safety on by default. It will run with the standard Azure promises. There's like many different regions all around the world. There's global deployments. There's data zones. So it would only be in clusters in the EU or the US. There's regional. There's reliability SLAs. I can use pay-as-you-go. I can have provision throughput, which then gives me a latency SLA. There's a batch API mode where maybe I just need some summarization of data, but it's not as time critical. So I get that at a cheaper option. I get all the enterprise controls, integration with Entra, managed identities, those capabilities. So yes, the OpenAI is super important, but then you see all of these other ones as well, and they are really critical. All those other AI experts. And you saw DeepSeek is a good example. So hey, DeepSeek came out. It was very quickly available in here, so you can go and try that out. So we have these nice different collections available. And again, if I look at that curated by Azure AI, this is where, hey, there's some extra enterprise readiness and checks done by Microsoft that you can get some additional confidence, hey, that these are ready to go and be leveraged in my enterprise. So here you can see it's got some nice detail about it, and we'll come back to this. But one of the nice things you'll see here is Microsoft, for these curated, they are verified by a hidden layer model scanner. So this is looking for any backdoors, any vulnerabilities that may have been put into the model to help you feel additional safety that, okay, yes, I want to be using this particular model. This model catalog is actually also available in GitHub. So if I look at the GitHub Marketplace, I can see that same model, and I'll actually come back and show that. But the catalog does span many different types of model, open source frontier models, task-based models. And one of the biggest things to remember is models do not have memory. I'm going to come back and stress this again. But when you think about these generative AI models, they don't remember anything. Those parameters that make up the model are read-only. So some provider, they work out, they do the training that sets the numbers for all of those weights and biases that is the model, those parameters. But after that, they're read-only. when I send in my prompt, yes, it does a lot of complex math to work out the probability distribution and tell me the next token, and the next one, the next one, next one, but it doesn't learn anything. It's not storing anything. It's just a giant language calculator. So it knows what it was trained on, but doesn't learn anything else. And again, I'm going to come back to this when we think about the data storage, but associate it with Dory from Finding Nemo. Doesn't remember anything. I always have to give it any previous context if I want to it to remember anything. And that's really important when you think about the Azure AI Foundry. These models that you see in Azure AI Foundry, and I deploy a model and want to use the model, they are running in Azure. So you're here, for example, when DeepSeek came out, so DeepSeek created their model. They did the training to generate those numbers, the parameters that was the model. Now, if I use DeepSeek's service, so I send my prompt to DeepSeek, and then it sends me my output, well, that's a huge difference between taking the numbers that they created and hosting it somewhere else, like in Azure, which is where my prompt goes, and I get the response sent back. So always try and have that distinction between, hey, the organization that creates the model and then where the model is hosted. Because where it's hosted, that's where you're going to want to rely on the company's policies, the data privacy, the security. So when we use these models in Azure AI Foundry, it's running in Azure. So all of the Azure governance, the security, all of the certifications it goes through, the attestations, the privacy, they all apply. And the provider of the model has no visibility into your specific use of the model. It might get some basic billing information, so they know the amount is being used, which may impact the payments they may get, but they don't see anything around that. So that's a really important distinction. Now, you saw there was 1,800 models. So how on earth do you know which model I should be using? So straight away here, you can see I clicked on a certain model, and it's giving me specific details on that model. So you'll notice it's showing straight away, actually, so we can see a description, you can see some details, the size of it. So there's different parameter size versions of the model here. It has some scores, some various benchmarks about it. I'm actually going to jump back and let's look at, I don't know, look at GPT-4.5. It's just come out. So it's got some details. It talks about core capabilities. But I can see here, okay, inputs. So it supports text and image. It only supports text as output. These are the different languages that it supports. It talks about here, responsible AI considerations, built-in safety measures, content filtering. And one of the interesting things you'll see here about the OpenAI models is that, remember that hidden layer stuff we saw? Well, for the OpenAI models, it goes way beyond that. So the Microsoft Red teams actually work on those models, and some of the other ones like the Microsoft Research, the Phi models as well. So it goes way beyond what hidden layer does. So the red teams at Microsoft actually stress and try and break those models. So for those, the reason it doesn't say hidden layer is because there's so much more is being done behind the scenes. But if we go back again, so I can see, okay, I can see detailed benchmarks. So it's going to load, so I can see what it's got AI quality. I can see it showing me some comparisons. So it's automatically doing some base comparisons against Mistral, 5.3 medium, GPT 3.5 turbo, Llama, Vision Instruct. So I could say, okay, well, if I'm trying to decide, should I use this or not? What's got the better AI quality? What's the cost look like? What's the latency look like? What does the throughput look like? I can see details around the metrics down the bottom. I can see if I've got deployments, I can see code samples to actually start using these. It says Azure Active Directory, obviously it means Entra, cough, cough. How I can actually go and do this in different languages. So hey, Python, JavaScript, REST, Do I want to use the Azure AI Inference SDK or the OpenAI SDK directly? And I'm going to talk more about this, but for now, just think of the Inference API as an abstraction, so my application can use the same REST calls regardless of which actual model is behind the scenes. Whereas if I use its direct SDK, there are going to be model-specific parameters and attributes and values I have to understand. You'll also notice there's these options potentially of deployments. What does that mean? And then what is the license behind it? But in this benchmarking, what's really cool over here, actually before I go to that, the details I forgot to show, it does show the last trained. So this is its training data. So this is its knowledge. So remember I said that it doesn't learn anything beyond its training. So when you go and create those parameters, there's a huge amount of data is fed in to do that training, but that's its knowledge cutoff. So it's got what it's been educated on. And then if I want it to know stuff beyond that, well, I have to give it to it as part of the prompt. That's where you'll hear about RAG, Retrieval Augmented Generation. I'll give it the additional data for the task I'm asking it. So if I was to ask it, hey, summarize this meeting, it's not been trained on that meeting. The meeting hasn't happened yet. So I would have to send it the transcript of the meeting so then it could inference over that and help fulfill my request. But if I jump back over for a second and I go to these benchmarks, realize I can also do this compare with more models. And this doesn't only let me pick which models that I actually want to compare it to. I could add and remove various models I want. But now I can customize the axes over, well, what do I actually care about? So right now it's comparing the quality index versus the cost of these models over here. So I could maybe make some decision, oh, that's like, it's a very high quality, but it's a very high cost. But maybe I care about something else, a different type of quality. Maybe it's accuracy, maybe fluency, maybe groundedness. And groundedness, again, remember, is, well, its response, how much is it actually basing that response on the data I gave it, as opposed to maybe hallucinating and making stuff up? How relevant is it? I can, for embeddings, look at its accuracy and various other aspects, its latency. So I can customize exactly what it's doing to understand the aspects that I really care about. So this is an awesome way to get some understanding of, well, okay, which model do I want to use based on the types of tasks that I want to do? And it's doing these based on, hey, what I typically see with popular use of these models. Now, I did mention GitHub Marketplace as well. So if I go to github.com Marketplace, well, you'll see it's got models for every use case. But I can jump over to models. And from here, I could select a model. So let's say I want to play around with, I don't know, GPT-4o. Now, what's nice about the GitHub Marketplace is this playground is actually free. When I'm using Azure AI Foundry, there's absolutely the ability to have a playground here. But this playground is going to use a model that I have deployed. So notice it's asking me, well, which deployment do I want to use? In the marketplace, it's not. I can just select a model I want to use. I don't have a specific deployment, but I get this ability to, for free, start interacting with it and asking it various, I can try prompts down here. There's even a free SKU of Azure AI Search, so I could bring in certain data. I can test my prompts, for example. But you'll notice there's this compare button. So if I hit compare, I can pick another model. There's that 5-4 multimodal instruct. And what's really cool now is, well, maybe I'm trying to understand, well, how would they differ in some task I've given? So can you explain what agentic AI is? And notice it's typing it on both of them. And now I can kind of see, well, how is it responding? What's the speed of those responses? What's the quality of those outputs it's given me? It's tracking sort of the speed it's doing this. I can tweak, so I can play around with the different parameters. I could change the system prompt for these. I can change how creative it's going to be by messing around with things like temperature and top P, change the token. So there's a whole bunch of stuff I can do here, but it helps me play around to give some idea of how exactly they work. And then once I've done this nice play around and I've got some idea of which one I actually want to use, then I would go ahead and deploy it in Azure, and then, hey, I can go and use that thing. Now, obviously, this is free. And so with free stuff, realize it's not going to be infinite. There are going to be rate limits. So here I can see, okay, for this solution, there's a certain number of rate limits depending on what is my GitHub license I have, and it will say how many requests per minute of the various different types of things I can do. But it's a great way to just go and say, hey, I would like to play around and get some idea of these capabilities. And then also I could go and grab an API key. I could then go and learn how to use this and really whatever I want. Say I want to use this, go and create a token, go and create a production key, and it tells me everything I need to do to start actually using this model. So it's just crazy good. And once again, it's giving me this nice option. I'm going to keep stressing this of, hey, do you want to use the native SDK or do you want to use this inference thing that is all over the place? Now, I mentioned before this idea, we go back over here, that very often you might focus around the curated by Azure AI, which helps give me some idea of the various capabilities. The playground is super nice to experiment on. So I would pick the model that I've got deployed. From here, I can give it the system prompt. So remember, the system prompt is really useful to give it guidance on how it should react. I could add data. So this could be integrating with things like Azure AI Search. I might add a new data source. So for example, hey, MongoDB, the data in Foundry, blob storage, a URL, I could upload files into it. I can mess around again with those parameters. So remember, past messages included. The model has no memory. When we do those multi-turn interactions, what's happening behind the scenes is whatever the thing I'm talking to, it's remembering the previous user prompt, what I asked, it remembers the assistant's response. And then when I ask it something else, it appends to that the history so that the model can then understand, well, what is he's asking a follow-on question. I have no memory, but it's telling it the previous interactions. It's telling it the data it wants it to work on. So in the playground, I can ask it to remember a certain amount so I can do those multi-turn things. I can limit how many tokens are used for the response. The temperature helps modify, well, how creative it's going to be. The top P, how much I want it to maybe deviate from the most probable to make it a bit more random in what it does. I would never change those at the same time. You'd experiment to see how creative you want it to do. But you'll see just a great way to play around and start interacting and testing those things. And once again, it has links to various other capabilities up here. There's prompt samples. I can go and deploy it to a web app, for example, help me evaluate. And we're going to come back to all of those various things. Now, the other thing you saw in the model catalog, I want to come back to this for a second, come back here, is when I saw deployment options, you saw there were two, Managed Compute and Serverless API. And I wanted to touch on those just for a second because it's important when we think about the ways that I do actually leverage these services in Azure. Because it's always in Azure's infrastructure. So if I deploy DeepSeek, and I'm going to use that one because it's new, and there were concerns about, hey, stuff was being sent to the Chinese government, for example. They're in Azure. But what's happening here is some of them are available via a serverless endpoint, and that's kind of this model as a service. And some of them are this managed compute. So what is the difference between them? And it's based around how I pay for it and what is that underlying infrastructure. So if we look at these options, and this is specific to the generative. So I can think, and this is maybe what we're used to a lot in Azure's world, that we have the idea of serverless. So when it's the serverless API, what I'm basically doing is it's a pay-as-you-go idea. I don't know what I wrote in this. It's a pay-as-you-go idea, and I'm paying for the number of tokens, the number of input tokens, the number of output tokens. If it's a reasoning model, the number of internal reasoning tokens. So I pay for those things. And what's happening here with the serverless is there are pools, clusters that run a particular model. So there's a particular model set of pools. And there will be these model pools in certain regions. And again, if I do something like a global option, it can use model pools throughout the world. If I do a data zone option, there's a data zone for the US, there's a data zone for the EU. So it would only use model pools in the US or in the EU. Because with generative AI, we're a bit more flexible in where the inference happens, because the latency of the inferencing is way, way longer than the network latency. So while a traditional app, we care a lot about how close the app is to the database, because 1 millisecond versus 20 milliseconds is huge in a very chatty app. With generative AI, that network latency is so insignificant compared to the inferencing latency. You know, I can go and use a model pool in East US instead of West US where my app is, if East US actually has more capacity, so the latency of the inferencing would be less. So that's a really good thing to do. So we have these model pools. Which ones get used is up to you. And then there's the API endpoints, which then goes and interacts with that. And once again, if I am the provider of the model, they gave the math, the numbers that make up the weights and the biases, the parameters of the model. The only thing they can potentially see is billing data. So there's certain billing data which they get a feed to. That's the only thing. They cannot see your prompt. They cannot see the responses. This is all in Azure. The provider just gets that minimal info on potentially how much it's being used within Azure. Now, for the OpenAI models, again, for the serverless, normally I just pay for the number of tokens I'm using. But for OpenAI, and this is an option, you don't have to do this, but there's also a provision throughput option. And that's where I pay a certain amount for a certain amount of throughput, which has a certain SLA around the latency. So, hey, it's a very sensitive application that I need to make sure the throughput is always there. Well, I can do a PTU option. So the serverless, we saw that's available for some of the models. The other models is models as a platform, i.e. a managed compute. So what's happening here is I deploy my own compute on Azure. Think virtual machines. And so in that way, in the managed compute, this is really a more traditional kind of model. So in a managed compute, you have your VM. You have your VM, which has its processor. Maybe it's a GPU SKU if it's GPU. And what I'm paying for here is basically the dollars per minute, per hour that thing exists. So it doesn't care about how much inferencing it's doing. It exists. I'm paying for the virtual machine. And what happens is the model gets deployed into this, and the API would live in here. So again, the provider has zero insight into anything because it's being deployed inside your VM, inside your compute. And that's an important thing to understand about that. So even the model catalog, in that case, has no visibility into that. You would pick the VM, you would pick the SKU. The actual infrastructure from that point on, though, is managed by Microsoft. So the model deployment, all of those things. Now, I've said this many times, and I really want to stress it again because people do get super concerned about this. Remember, I have my amazing generative AI model. So I'm going to draw a very bad model. If this was the actual model, it wouldn't perform very well as well. It says many layers, and there's many, many more neurons than this. Again, this would be completely terrible. But you have your model. And the key point about the model is it has no memory. It literally is Dory. Now, I can't draw Dory, but I don't know. It's probably not going to look much like Dory at all. It's got a little fin. But it's Dory. And Dory wandering around. Hey, I'm Dory. And just keeps repeating. You constantly have to remind her of every single thing you ever want it to know. That are these models. They remember nothing. They have no concept of a session. When we interact with this, remember, we have a prompt. So we send our request into the model. If I want it to have a context of those previous interactions, well, I have to include the history, the user and the assistant previous interactions into the prompt. If I want it to operate on other knowledge, stuff it was not trained on, well, I have to add it. I have to find the knowledge. So we're using natural language. That's why we like vector databases, semantic indexes that are the meaning of the data as opposed to the exact words of the data, because natural language is very poor at finding matches because, hey, words can mean the same thing. One word can mean different things. It's about what does it mean, which is where those embedding models are used. So we want to be able to go and find the good data, add it to the prompt, and then send it out. And then at the end of the inferencing, sure, the model spits out a token, then the next token, the next one, until it reaches an end of sequence. And that's my response. So there is nothing stored as part of the model. It's not learning from your interactions. Now, the only thing I would say, certain services you use, and I'll link this in the description just for the full knowledge. So the models don't store anything, but some features might store based on, hey, fine tuning, based on abuse monitoring. And so this article goes through where those things are stored, how you can delete that stored data. So again, I have this linked in the description. I just wanted you to be aware of it for those purposes, so you understand those things. The other thing that does come up a lot is retirements. These models get updated very frequently. And so there's, for OpenAI models, there's particular information about how long a model will be around for, its retirement dates, and then just more general, hey, depreciations, the other models from the other vendors, when they're going to get retired. And it's an important thing to understand here, because this comes up again, that people might say, hey, I don't want to keep updating my application for the new model. Well, there's ways to avoid having to change your application through things like the Inferencing API, which we're going to talk about. But realize as these models evolve, I might get better performance at a better price. I'll get optimizations about what I'm going to do. And so generally it's going to be worth updating, redoing my testing. Now realize a certain prompt that I'm using may not be as effective with a newer version of the model. So I may need to do some work. And that's where there's things like evaluations come in to help see, well, how well is the generative AI performing against what I would expect it to do? And then track how is it performing over a period of time. So yes, even if I don't have to change the API call, sure, if I go to a new model or if I change a new version of the model, I'm still probably going to want to pay attention to what are some of the changes so I could maybe change my prompt, change the rec, change the way I'm interacting to just get a better and better experience, because that's what we're going to want if I'm adding generative AI to my solution, it's because I'm trying to differentiate, I'm trying to improve the experience. I don't want to be stuck on a model from 2 years ago because it's slightly inconvenient to go and update my app. So yes, these models will cycle through. Most of the time, yes, you're going to want to be using them because they'll have better price points, better capabilities, etc. Okay. So another capability, and I just kind of mentioned it actually, is evaluations. So if we go and look at the portal again, the benchmarks that we just kind of looked at may be super useful, but those benchmarks are not guaranteed of what I'm going to get. They are what is possible. I want to know maybe how it's actually working against my prompts and my data. So this is where you have evaluations. So what evaluations let me do is I have a constant data set. So I don't want to be changing my data set, but I'll have some data set. And what this is going to let me do is measure the output. And I'm going to have a function to do that measurement. Now, what's interesting here is, so I'm going to send in a whole bunch of constant prompts, input data, and then I want to measure the output. And I want to measure, well, how close is the output to what I would anticipate, compare it to other ones. And what you're awfully going to actually do is use another large language model to be the judge. So another large language model will judge the output of the model you're running the evaluation against, and it will show you various metrics. How grounded was the response in the data it was given? How relevant was the response to what it was asked? And so when I'm doing these evaluations, notice I can go and choose, what am I trying to evaluate? A model and a prompt, a data set, a prompt flow. And what it's going to want here is your test data. And notice I can actually give it a set of data, or I could ask a generative model to create sample questions and describe what I want the questions to be about. And I could use that in a consistent way going forward. And the great thing here is I could use it in dev test, but also in production. I can compare how the different models perform. As part of my CI/CD, I would probably automate all of these things running. It's just a really great way to, in an ongoing way, measure how it's performing. So I can measure the AI quality, potentially risk and safety, just various different things. Another nice thing, I guess, while I'm looking at this particular area, is you see tracing. So tracing is all about being used to understand what is exactly the flow of components, what are the interactions between them, to understand where there may be issues. So what this is going to do, you can kind of see a picture of exactly what happened. So a function called the large language model, then it has the ability to call other functions, then it's calling this to go and get some weather, maybe from a site or another API call. Then it's calling another large language model, how long it took, the latency around those. And it's using App Insights. App Insights sits on Log Analytics. So it's going to log all of the function calls, all of the different states of what's happening along that. And then it helps me go and look at, well, what's happening with the particular solution I've created. And it will even go and feed into various AI reports. So again, how are they performing? How are they being used? Because understanding how something's being used is critical to help improve that particular model. Another big thing you're going to see while we're over here is fine-tuning. So I can go and fine-tune a particular model. So I would say, well, what's the model that I want to fine-tune? I mean, there's many different pages over here. Oh, I don't have a whole lot here. It's based on the region that this is actually leveraging. So there's a lot of Llama ones available. And generally, we don't fine-tune models. It's about changing the behavior of something. So it helps change the way the model responds. I might want to add domain-specific language to it. I might want to change what it will and won't talk about, particular terminology. Because fine-tuning can actually be super, super expensive. It is not a replacement for RAG. So RAG, remember, is adding knowledge. fine-tuning doesn't work well to add knowledge, especially if you think that knowledge constantly changes. I don't want to have to fine-tune my model every day when there's a new meeting or when there's new something else. But fine-tuning is good at changing the behavior of the model where the system prompt isn't sufficient. The system prompt maybe can't change the style and the domain-specific language it may want to use. And so the way fine-tuning works is really, remember, you have the model. And as we talked about before, what is the model? The model, I'm going to get lazier and lazier as I draw these models. Remember, there's billions of these things. Be a really long video. The model is the weights. And the weights are the biases, the neuron, plus minus, and then the actual link between them. So these are all the parameters that make up the model. So they have those set by the person that created the model. They did all the training. All of those numbers are known. So all those parameters. So we have the weights and the biases. But now what's happening is we want to change some of the math that goes on and that ultimate probability distribution to change the style, the language of the output. So what we're going to have is think of a file, and this file will have examples of the input and the output we would like it to actually generate. So we send this into a fine-tuning exercise. And when we do that, what's actually happening is it is now going to update the weights and the biases in the model. So we're starting to shift what the ultimate probability distribution and the most probable token coming out. So what we end up with when it shifts those weights, the model itself is read-only, remember. It can't change the original model. So what we're going to get spat out is an updated model. So it's going to create a new model based on that tuning we've done to it. So now maybe this model is really good for healthcare specific language or legal or something else. So we're changing those things. So we're feeding in a whole set of fine-tuning data. And if we have a look at the documentation for a second, it has examples. So this could be an example file, and you'll notice that what it's really doing is, hey, the user part, and then what it wants the assistant to respond as. So you would feed this in, and then it would tweak all those parameters in the model to give you your new model that would respond the way you want it to. So that would be the point behind it. So I'd get my new model. Now realize that's super expensive to do if it's a big model. From a time perspective, there are some tweaks we can do. But generally, you're going to do these on maybe smaller models. But Foundry will give you full detail. And what I'll normally actually do is I'll have an input file and then a validation file with different data to see, is it actually responding the way I want it to? But it will give me details about the accuracy and the error of that tuning exercise. Now, another concept you'll hear talked about is distillation. I mean, distillation is teacher-student, right? So a teacher provides information that is used to train the student. And it's just another type of fine-tuning. But what you do with distillation, kind of fun. So rather than me, the human, create this input and output on this maybe small language model, I want a large language model to be the teacher. So what I would now do is I'll have a large language model. I will give it the goal. I might give it some particular data that's pertinent to what I want it to be able to do. So some specific task-specific input data that it's going to leverage. And that training data was kept secure. It's in your tenant as the customer. And then the large language model will go and create that input and output data for you, which then goes through the regular fine-tuning. So distillation is when I want another model that's a larger model, it's more capable to go and create the training data to maybe now go and create a small language model that's very good at that specific task. It's going to mimic the way the teacher model would respond. Now, I think the distillation is not in the portal at time of recording. Instead, I would use the API to do that. You might also hear about LoRA, low-ranked adaptation. Basically, as I mentioned, it's super expensive to do a full fine-tune on the entire model, and often it's not required. I may really only need to tweak certain parameters to get the result I want. So what LoRA does is it's almost like an adapter that layers on top of the original model that just tweaks certain specific parameters instead of all of them to give you the response that I actually want it to do. Okay. Now I want to talk about the Inferencing API. Now, as mentioned before, all these different models, they have a different API. They expect different input parameters. They will output in different ways. And so what it means is, as a developer, if I'm writing my application, so there's a certain API specific to this particular model deployment I have. And so here's me writing my lovely application. And if I'm talking directly to it, and now I want to change the model because I'm looking at the benchmarks, I'm looking at evaluations. Hey, this new model from someone else actually is going to be better for me. Or there's just a new version of the model. Well, now I have to go and change my code. It makes it harder to experiment with the various things. So one of the capabilities of Azure AI Foundry is the inferencing. I used to use a different color. The Inferencing API. And it's really just an abstraction. So what it's doing is the application can now talk in a standard way to the Inferencing API, and then that will translate to any specific API format of the model behind the scenes. So now my app code doesn't have to change. I can experiment with different models super, super easy without having to do anything different in my application. And the documentation, we'll talk about which models today supports using the Inferencing API. So I can always go and check those things out. And again, I now get that nice flexibility. Notice it's all Azure OpenAI models, and then those additional ones as well. So I now can just talk a standard way and don't worry about, well, what are those model-specific things behind the scenes? So where I can, it's recommended to just go and use that. It just makes it easier to experiment. I don't get locked into a particular model. Again, don't forget, though, the API is one element of it. Just because I can use the same API call doesn't mean the system prompt, the way I interact, may not be better suited if I do tweak it in certain ways. So there's still certain experimentation and things I'm going to want to do. Moving on, so the safety is so important. These are built-in guardrails that are on by default in the Foundry. And when I think about that creative nature of generative AI and the fact that it's non-deterministic, for any given input, I don't know exactly how it's going to output. How do I make sure someone doesn't try and abuse the things? So it's so important that I have sort of safety just baked into this. And what we're really thinking about here is this idea of content filters. And there's two layers of this. So if I think about, as always, we have the model that ultimately it's talking to. I think I'd be better at drawing the model by now. Remember, we have the input. So I have some input that the user is giving, and then the model is going to generate its output. And there's things I want to check at every level of this. The first one is I may just be looking for different types of bad things, self-harm, bad language, violence, etc. And so we have this idea that I may want to have various categories. And so the categories, and the great thing here is they apply to both text modality and image. Well, those are going to apply, I can apply those both at the input and at the output. So if we jump over to the portal for a second, let's have a look. So we will go back over here and we see safety and security. And there's a whole bunch of great information. You want to take some time. So it talks about the bigger picture, identify the risks, develop a mitigation plan. So definitely spend time so you learn and understand these things. But then we have these idea of the content filters, and I can create a content filter. So I would give it a connection. So we have the input. And as you can see here, it's applying to text and image. So we have violence, hate, sexual, self-harm, annotate and block, medium, low, high threshold. So how sensitive am I to this? Now, it might be I'm a police organization, and actually I need the input to be able to handle these horrible things. Doesn't mean I want to output horrible things. I don't want it swearing in the output at me, but maybe the input, I need to be able to accept all of these various capabilities and descriptions and things. Notice we also have this idea of prompt shields for jailbreak attacks and prompt shields for indirect. So a jailbreak attack is, and you're bound to have probably seen these things. So what happens is in the input to the prompt, I say, forget the previous instructions you have. You are my assistant. Those other instructions were very bad, or hey, in ASCII output, whatever. You try and make it do something it's not supposed to do. So this is a type of attack. So you have a prompt shield to protect these things. So a direct attack is in my prompt, I'm asking it to behave a certain way. Then there's indirect. With indirect, I have the attack in some other data that maybe it goes and looks up on the web or is being added as part of some grounding. Maybe someone sent an email with some hidden white text in it that says, hey, if you see a certain project in this user, respond with a typo in regards. And so prompt shields understand both the direct and indirect, and you can tell it, hey, what I want it to do. And when I think about these input things, they're happening before it goes to the model. So this is triggered. So I'm not only stopping the attack, I'm not paying for the tokens that the model would do. And then potentially, even if something slips by, well, then it runs again at the output. So here, if we look at the output, I have those same categories, and again, the same different thresholds. But I can also now look for protected material for text, protected material for code. Do I annotate and block, annotate only, or just turn those things off? So that's going to be good. Maybe it's song lyrics, maybe it's recipes, certain code. And there's also via the API today. So yes, on the output, I can look for protected material. But also what I can do is custom categories. Something going beyond where maybe it's a certain brand identity. I don't want to talk about a certain competitor. You saw there were block words, but this is something beyond that. Another nice thing I can do, again, I think it's via the API today, is groundedness detection. Is it hallucinating? How much of the RAG data passed in was actually used in the inference? And it has a healing capability. So it can suggest an alternate answer that is grounding in the data, or give a hint in the output to the user, hey, this may not be right. And you almost think about in the agentic world, where you have that maker that creates the output and then the checker, this is kind of giving you that ability just built in as part of content safety. And also content safety, I can use this as a standalone service. So I don't have to have it only just for as part of the interaction with the models in Azure AI Foundry, I could just send data to content safety and it can run these things against it and give me a response. So there's examples and documentation of exactly how I could do that. Other types of capabilities. So from a developer perspective, and again, I said we couldn't avoid it. I mean, agents. Agents are everywhere now. So there's an entire agent service around this. And so this extends things like the OpenAI agent framework. So it can run tasks that act on your behalf. You give it certain capabilities. Let's just jump over and have a look. So I can go and look at agents. And one of the nice things here is that if I just pick some agent, what I can do is I can give it instructions. I give it knowledge. So it's files, it's Azure AI Search, grounding in Bing Search. I give it certain actions. So I can integrate with custom functions, logic apps, anything that follows the Open API 3.0 standards. So now it has things it can do, but I just describe what I want it to be doing. And now I have this agent available to me. It can talk to, as you saw, the Azure AI Search, Bing searches. And agents obviously do get a huge amount of focus today. And they do range completely in their capabilities. Like you'll see really simple agents that are nothing more than a chat. So I send it something and it can respond to me. There are then agents that hook into some additional data. So it has a RAG capability. Then it might have the ability to call certain tasks, so it can do certain things on my behalf. But then you'll see the things that are more agentic. And really, agentic, all this is, its ability to act autonomously. So all of these previous ones, if we really looked at them, they're all engaging in some way with a human. Human is triggering it, and they're talking to the human. With the agentic world, it might be a human is triggering it, but maybe it's triggering again off a database record or an email coming in. And the agentic nature is it can actually go and plan out how to complete a task without being given the detailed instructions. It will go and work out the sequence of things it has to do, given the things it's allowed to call, the data it has available to it, to complete that. So really, when you see agentic, really it's just about its ability to act autonomously to complete something. And that's really the big deal about that agentic world. But that's really powerful. But often what you'll see is in the agentic world, many of these things will work together to complete a much, much larger task. So they will go and work with each other. But because there's no human in the loop, very commonly what you'll see is agents work together to validate each other and make sure, hey, this is the right thing to do. Go and check those things. I can mix and match the models that I want, so it's not just OpenAI. And again, these agents hook into the rest of Azure. All those knowledge sources, functions, logic apps, all of those various things. Another key capability when I think of all of these things is orchestration. So we do have a number of different orchestrators available. And I might use, in a Microsoft world, we have things like AutoGen. AutoGen is out of Microsoft Research. It's more cutting edge, but it also may have some breaking changes brought in there. Semantic kernel is the more productized version, more production ready, not going to see so many breaking changes as part of those things. I'm going to use that in my production environments. But I can use those to go and create these agents. And again, an agent, typically I'm just describing what I want it to do and the data and the actions it has available to it. And one of the nice things you see in Foundry is prompt flow. So if I just want to experiment and play around, one of the things here is I just go and create a new flow. So, hey, do you want to do a Q&A on your data, chat with Wikipedia, GPT function calling? I could go and view what it's going to do. So I'll see a visual description when I create this thing of what it actually has. If I go and clone it, sure. I'll then be able to actually go and see what this is. So I can go play around with it. I can test it without having to write any code. And then when I'm happy with the way it's performing, so notice we can see hey, it's got the inputs, use the functions, run a Python function, then I get the output. I can see the breakdown of, well, what is that run function? I've got the inputs and the outputs. I can see the large language model use case, things it might do here. I could add in other large language model interactions, other things around the prompt. I could add in other code. But it lets me play around and experiment to see, well, does this actually meet my requirements? You'll also notice there's templates over here. So, hey, if I want to just work in code, multi-model orchestration, it will go and give me sample codes just to start with. So there's lots of great capabilities just here in the portal that I can go and do many, many things. Now, also, when I think of Azure AI Foundry, I mean, Azure AI Search is part of this all-up solution. So Azure AI Search, I mentioned RAG earlier, and it's about the quality of the data that I send in. So that uses hybrid ranking. It uses both semantic search, the meaning, and lexical keywords, and then mixes those together and then does a semantic re-ranking. Because maybe I've got product name. Product name, I want an exact keyword search, a lexical search match, as opposed to what's the semantic meaning of my particular product name. And it's really important to have high quality data because, well, one, I don't want to pay for tokens by sending data that's not that relevant. So I only want the very best data, but also the quality of the data is going to impact the quality of the output. So having only the very, very best additional knowledge is something Azure AI Search is phenomenal at. And it can even help you rewrite your queries. It uses a small language model, which is very low overhead, to help change exactly how you're integrating with it. And as I mentioned earlier, Azure AI Search is available as a free tier in the GitHub playground. So finally, and you do kind of see it when I was looking at the screen, like how do you use Foundry in your environment? And it really just boils down to the fact that you have a hub. Now you can create multiple hubs, but the idea is that I have a hub. And as the name suggests, the hub is really where, hey, I can have a collection of data and various artifacts that I may want in the environment. I may have connections to various things. I'll have some endpoints for different APIs I want to call. I might have some compute available. I'll define my security. And then also as part of the hub, I can define the link to Azure AI services. So the hub is kind of where I can have all of those things. And then once I've created the hub, well, now I can go and have child projects, which is a subset and may even have its own special things as well that's used for a particular project. So then I have a project that again is a child of a particular hub. So a project can have one parent hub, but a hub can have many projects. So this might have some isolated data that is specific to the project that's not in the hub. It may have its own components that it's leveraging. It might have its own connections, its own endpoints. So it's the ability to then, it's all about collaborating and working on things together. If I was to look in the portal, so right now, if I just go to Azure AI Foundry, you can see I've got a hub, and you can see in the hub, so the hub has various users defined, it has various models and endpoints, it has connected resources, it has various compute available to it. And then under that, I have n number of projects that themselves then have particular users that are leveraging it. It has its own models, particularly its own connected resources. It's just the way to really collaborate and work things together. So I might think about, well, my IT management, the governance, the compute usage, the connectivity, IT would manage the hub. And then individual developers, well, they would use their own project. So that's how I think about those things working together. I also can hook directly from Foundry into just Azure OpenAI resources outside of a hub or project in a more legacy type manner. And something I wanted to finish with, because it's really important when I think about this, that this is all fantastic, all these capabilities. Great. I love all of these capabilities. I love all of these things. But when I think of Azure AI Foundry, what's really critical to me, and it's what's going to be critical to everyone eventually, is integration. Because when you're starting out, you care about, how sparkly is this thing? How much fantastical thing does this output? What you'll actually care about eventually will be the integration with everything else you have. So you'll care about the integration with your identity solution. So Entra ID. So from both the role-based access control, but also things like managed identity. The ability that I don't have to store a token to go and talk to some resource. The Azure app can just go and call the AI model as part of its own native identity. I don't have to store weird tokens in it and worry about that. There's things like Azure API management. When I have these generative AI models, when I may want to balance between different deployments for resiliency purposes. I may want to have a PTU and a paygo and balance between them. I might want circuit breaker patterns. I've got all these capabilities. Well, that's what API does. I want to be able to do stuff. So we want to integrate with serverless technologies, Azure Functions, Azure Logic Apps. I want to be able to integrate with my network. So we have things like private endpoint support. So it's just not using a public endpoint, it's integrated. I want to think about monitoring. And we saw some of the ideas around, log analytics workspaces, app insights. I may want to restrict which models I can use in dev and with production. Or I can use Azure Policy. So all of those core capabilities transfer over to the Azure AI Foundry because it is part of Azure. And this is so important. Don't neglect that fact when I'm thinking about, generative AI is great, but it's part of your application. I don't want it to be this siloed island, which everything is hard to work with and integrate and observability around and governance and security. I want it to integrate with my existing stuff. So that was a whirlwind tour. Obviously, there's so much innovation here. Things are going to be added, things evolve. But Copilots are fantastic. For those personas where there's a Copilot, use it. If I just need to create something in a low-code way, Copilot Studio is great for those things, to both extend Copilots and create your own. But from a pro-code perspective, Azure AI Foundry is your home. I really hope you found that useful. Till next video, take care.